So for this problem, you have got a car that is moving and the light turns red so the driver hits their brakes. So if we graph velocity versus time, the velocity starts at some value and it goes to 0. Okay, so this is a velocity versus time graph. So there's our diagram. Delta x is the distance we go, and that is given to you in the problem. So that equals some number, let's just say 70 meters. The initial velocity is however fast the car is going initially, and you've got to watch out. This is in miles per hour. So for example, if it's 50 miles per hour, we're going to have to convert that. The final velocity, of course, is 0 because it's not moving at the end. It comes to a complete stop. The acceleration is unknown, and there's also time, but we don't know that either, okay? So your first step for this problem, for number 4, is to convert your velocity. So step 1 is to take 50 miles per hour, or whatever you have. That's per hour. We're going to multiply it by the fact that there is 1 hour in 3,600 seconds, and we're going to multiply it by 1609 meters in 1 mile. So that way, the miles cancels the miles, the hours cancels the hours, and you are left with meters per second. Okay, so you'll have to figure that out and get that value. And that, of course, is the initial velocity. Okay, so figure out what that is, and let's just say that's 22 meters per second. Okay, I don't know what it actually is. All right, the second step you're going to do, so here's step 2. We have to find the acceleration. So we don't know the time, so probably the best plan is to use this equation. Final velocity squared equals the initial velocity squared plus 2a delta x. We're going to solve that for a. So to do that, I'm going to take v final squared minus v initial squared. So I'm just going to take this term here and bring it to the other side by making it negative. And that will leave me 2a times delta x. Remember, I'm trying to find a, so I'm going to divide this side by 2 times delta x. So I got to do it to this side, 2 times delta x. Okay? So that just means that our solution, 2's cancel, delta x's cancel. Our solution, a, equals the final velocity squared minus the initial velocity squared divided by 2 times delta x. So you will take whatever initial velocity you get and plug it in there. The final velocity is 0, and you know delta x, it goes there. You can find the acceleration, okay?